Hello everyone, welcome to Pepcoding. So today in this video we are going to see that how to construct a binary tree from pre-order and post-order traversal. So here let's say this is a tree given to us. Let's write its pre-order and post-order. I'll just write its pre-order and post-order. I hope that there is no problem in writing of pre-order and post-order of these trees to you. Uh, just I'll just give a quick recap that how we used to write the pre-order. What we used to do, we used to draw these lines on the left side of every node, and then we used to start our Euler's path, and wherever this Euler's path was going to intersect with these lines, we used to write those values as it is. That is, we used to write those values in that order only. For here example, we used to write first the Euler's path is intersecting at A. We used to write A here, then B, then D, and so on. And for the post order, what we used to do, we used to draw lines at the left side of these nodes, right? And we used to do the same technique, that wherever this Euler path was going to intersect with these lines, these green lines, that is those are made on the left side. Wherever these lines are going to intersect these, this Euler path is going to intersect these green lines, we used to write in that order. For example, here D is going to come first and then F is going to come first. Why we used to do this? Because we know that this property is that for post order, first node is going to be visited, then left child, and then right child. And similarly for this, first left child, right child, and then node. So I'll just complete this pre-order and post-order array. Just give me 1 second. So here we have written the pre-order and post-order of this tree. Now what this question is asking us, that we will be provided with these two arrays and we have to create a tree something like this. And the one condition that is one constant is that this tree is going to be a full binary tree. As you can see that this tree is a full binary tree. So what is the definition of full binary tree? It is that every node is either going to have 0 children or 2 children, right? There is no child that is going to have 1 children. So let's start with the solution. What actually we are going to do? If I know that this first node is going to be the root node of from the tree, I'll just write it as it is, right? Now what we used to previously do, we used to previously find this A in the next given array, right? We used to find the IDX. We used to maintain an IDX, that is the count of the elements that was going to come in the left subtree and in the right subtree. But here if you see that this A is present at the last location, that is the last location of where? Last location of post order. So how to determine that which nodes are going to be in the left subtree and which nodes are going to be in the right subtree, right? There is no relation. But if you observe carefully, you can see that, or you know that the next element, that is in the pre-order, the next element that is going to come is going to be in the left part. As it is a full binary tree, it is going to be in the left subtree, and that is going to be the root node of that subtree, right? So here B is in the left subtree and B is the root node, or we can say that B is the parent node of this subtree, right? You can see this. So here, instead of finding A, what we are going to do, right now currently we are standing at A. Instead of finding A in the post order, we are going to find B. That is, we are going to find an element that is having one index more than it, right? Which means I'm going to find B. And here if I find B, somehow I maintain somehow I found the total index of B. For here for this question, it is going to be at 4. Somehow I was able to find the index of B. Can I find the total number of elements that are going to be in the left subtree and that are going to be in the right subtree? Here we can see that these are the total number of elements that are going to be in the left subtree, right? I'll write it as left subtree. So to find that, can I write that if I have some pointers, let's say pointers are something like pre-orders starting index, pre-orders end index. Here post orders starting index and post orders end index. if I have these 4 pointers, right, what are these pointers? One is starting index of pre-order, second one is end index of the pre-order, then similarly post order starting index, post orders end index, and also we are going to maintain one IDX, that is index. This index is going to be of which index? This is going to be the index of the element, that is the next element of the root node, that is for this B, and that is that we are going to find in where? We are going to find in post order, that is the second given array, right? So here we are able to find B here, and index of B, this B was 4. So now is it possible for me to find out this total number of elements? These total number of elements are what? This left part is going to be my total number of elements that are going to lie in left part, right? That is going to be in my left subtree. So can I write here as it is going to start from where? It is going to start from post index, right? That is post orders starting index. So I'll just write it here as post instead of post order. Can I just say it is going to go from post order starting index to where? Here IDX was maintained, IDX, then to IDX till IDX, right? I can say this. So what is going to be the count? The count is going to be 0, sorry, 1, 2, 3, 4, 5. I have to include this B also. So here answer is coming 5. That is, I am trying to say is we are now going to calculate from post index, that is the element starting from the post index starting index, right? Sorry, post index, I am saying post, instead of post index I can say that post orders starting index to the IDX. So to get the formula, that is get the generalized formula, can I write here as IDX minus post orders starting index plus 1. Let's see if it is satisfying or not. For this condition, let's say IDX is 4. We'll just write it IDX as 4 minus. Currently my post order starting index is what? It is 0 and plus 1. Is it giving me the answer 5? And we have counted that from post index to IDX there are how many elements? There are 5 elements, and after using this formula we are getting the same answer. So we can say that this is the formula to get the total number of indexes or total number of elements, right? So what we are going to do now further, if I set my A as a root node, I am going to pick these elements, that is 5 elements, total number of elements, from this also, from this pre-orders array, that is 1, 2, 3, 4 and 5, that is till G, and I am going to send them in where? I am going to send them in the left side of the A, that is in the left subtree. So it is going to be B, D, E, F and G. Similarly, I am going to pick these 5 elements including B in the post order and going to send here. So these are going to be D, F, G, E, B. Now similarly, the remaining elements, that is from C to M are going to lie in where? Are going to lie in the right subtree of this A, right? So we are going to send them as it is C, H, I, J, K, L, M, and similarly we are going to send these elements. Now this is a important point to notice, that we are not going to send the rest of the elements. We are not going to send all the elements of the post order in the right subtree, but we are going to send elements that are starting from this point, that is IDX plus 1, that are starting from the next point of the IDX till the last elements, till 1 less than last element, that is till this point, till C. Why? Because A is already included at the beginning, at the main root node, right? So we know that in the post order there are as we have discussed, this is the main property. What was this property? First we are going to visit node, then left, then right. Here where we are going to visit first left, then right, and then node. So here node is always going to come in the last position, right? Therefore we are not going to include this in our right subtree, that is we are not going to include A in our right subtree. So we are going to send till where? From H to C. So H H, J, L, M, K, I, and C. Nice. From here, now we are going to do the same things again. We know that this B is going to be set as the root node in the left subtree, and for this part, C is going to be set as the root node, because this is our pre-order, this is our post-order. Pre, post. Now our starting index, pre-order starting index is going to be this, pre-order starting index. End index is going to be this, post-orders. So pre-orders, end index. Now what is this pre-orders end index actually? It is nothing but nothing but total number of elements plus this previous pre-order starting index, right? We will talk about this later. For now, just remember that this is going to be our, let's erase this. For now, just remember that this is now going to be our new pre-orders end index, and similarly here this is going to be start index, this is going to be end index, and similarly for these two also, post orders start index, post orders end index, post orders start index, post orders end index, right? Now what we are going to do, we are going to set this B as the root node, C as the root node, right? Now we are going to find where this B is going to lie in the post order, and we are going to maintain a count. But again, as we have did in the previous for A, we are not going to search for this B, we are going to search for the next element of the B, that is going to be this D. So we are going to search D in the post order, we are getting D here, therefore we are going to send this, D and its count in the left part. So what are the values before D in the post order? There are no values, so D is going to go as it is, and similarly here D is going to go as it is from pre-order and post order. Now remaining rest values are going to go in where? Are going to go in the right subtree. So it is going to be E, F, G, and it is going to be F, G, E. Why not B? Because this is the root node that we have already included, right? This is our root node we have already included. And for C, what we are going to do, we are going to search for the next element of the C, that is H in the post order, and we are going to send its value before H, including H, in the left subtree, and after remaining values, that is values after H till one less from the last in the right subtree. So here values before H are nothing, so we are going to send H as it is, that is H and H, and before these values, those are going to be here till here to till here. So these are going to be what? J, sorry, not J, H, I, J, K, L, M. Similarly, here we are going to send what? We are going to send J, L, M, K, I, right? So let's say 1, 2, 3, 4, 5, and 6 values, right? Now again we are going to follow the same steps. For here, D is going to be set as the root node. Here A is going to be set as the root node or the main node for this family. For the below family, H is going to be set as the main family node, head node, and this is going here instead of this H. Oh, this H is not going to come. Sorry, this I is going to be set as the root node. Let's say 1, 2, 3, 4, 5. Right now this is right. Previously we counted incorrectly. Now I is going to be set as the root node. So here D is set as the root node, E is set as the root node, H is set as the root node, and I is set as the root node. We can also call this as the head node for this current family. So here in D's family there is no values present in the array. Therefore D is going to be the end node of this family, right? Here for E, F and G are remaining, and here also if I say F and G are remaining, right? So here we'll be finding value value 1 next, that is we are going to find for f in the post order. So here we are going to send f, that is f, and before it's, and here we are going to send g. As you can see that these two are going to lie on left and right side, right? So here f is going to go and g is going to go. Why f is going to be alone? Because previous values of f are nothing, so f is going to be included singly, and here therefore this f is also going to be included singly because total number of elements is going to be 1 only, and so on. G is going to get here, right? Now h is also the final node of this family. Now for this particular tree, this particular subfamily, subtree, what is going to be? We are going to find j in this post orders array. So here we are finding j here. So j is going to be here. The count of total number of elements is going to be 1 only. So j is going to be here. Now similarly, here what are the remaining values are going to be included here? Those are what? Those are KLMN, KLM, and here it is going to be LM, K, right? Why not I? Because I is already been included. Now we are going to do what? Same thing. F is being set, F has been declared as the head node, G has been declared as the root node, right? F, G, here J is declared as the root node. Here which node will be declared as the root node? K will be declared as the root node. We are going to find an element for L in the subtree, that is going to be here LL, and here it is going to be what? It is going to be remaining of, that is M. So here we can say that L and M are going to be set as the root node. If we circle this for our better understanding, you can see that our array is being totally used. Therefore this means that our tree is fully made. Now let's try to compare these values with our previous tree, right? I'll just try to fit this in. Okay, if you bring this array here, bring this tree here, and we try start comparing the values, we can see that A as the root node, then B was the second root node or second main node of the left subtree. So that is here, right? C is going to be here, C is going to be here, D is going to be alone, D is going to be alone. E is going to have two children, F and G. E is going to have two children, F and G, right? Now C is going to have one children, H, that is going to be alone, and second child as I, that is going to have some children. The first child is going to be J, and second child is K, Now K is having L and M. So with this we can see that our tree has been constructed fully. Now what was the logic behind this construction? I'll discuss it once again because I think this is necessary. What we are going to do, actually we are going to set the first node in the pre-orders array as the root node. Okay, so this node is going to be set as the A is going to be set as the first node, and now we are going to search for the next node, this or next value of pre-order in the post order, that is we are going to search for B, and somehow we are able to find the count, that is somehow we are able to get the index of the B in the post order. We'll be able to find the count, that is total number of elements that are going to lie in the left subtree, because we have to find the total number of elements with respect to, or total number of elements before B in post order, right? Before B in post order, that is these values. And if we get those values, we know that these values, that is these values, are going to be in the left subtree, and remaining values one less than the last value, that is one less than last value, because A is already considered here. So these values are going to lie in a right subtree. So what is actually going to be, if I try to simplify this and I say that if this is my root node, if this is my root, at any point, if this is my root, then if I have some pointers like pre-order starting index, pre-order end index, and post-order starting index, sorry, post-order starting index, post-order end index, and then two more pointers, that is IDX, and one value that is going to be total number of elements. So using these values, can I say that first for in the left side, what is going to go? It is going to be that from this value, from P, that is one value extra than my starting index. Initially my starting pre-order starting index is going to be 0. This is going to be n-1, that is the size -1, right? This is also going to be 0, and this is also going to be n-1, right? Index is starting initially it is going to be 0 only, and total number of elements we are going to find out. So initially, can I say that instead of sending 0 here, what I am going to send? I am going to send the next element of the pre-order starting index. So I am going to send next element of the pre-order starting index, right? And the end point, that is the end index for this subtree, is going to be what? This subtree is going to be total number of, if I say total number of elements, that is this point, that is just these values, total number of elements. So can I say that total number of elements, but before that I have to add this in my starting index, total number of elements. So let's see if it is giving me the right answer or not. Initially my starting index was 0, and what I sent as a starting index for the left subtree, that is for this, it is going to be 1, right? This is my starting index, this is my end index. So my end index is going to be sent as what? My end index is going to be sent as total number of elements. What were my total number of elements? That was 5, plus this 0, that is going to be what? That is going to be 5. Let's check. Is the index 5 is the index 5 going to be included? Yes, this you can see that this is going to be included. So till this point, till this 5, it is going to be included in this left subtree for this question. So therefore we can say that this formula, or this expression, is going to work. Now similarly, for my post order, what is going to be sent as in my post order? My starting index is going to be as it is. So can I write here as my starting index of post order as it is? Till when I have to till what point I have to include my values? If you remember, we have to include this values till this IDX, right? Till this IDX. So can I say that my end index is going to be what? My end index is going to be IDX, right? Now if I know the starting index and end index of the left subtree, can I find out my starting index and end index of my right subtree? Yes, we can easily find out. What is it is going to be? Obviously the starting index for my left subtree is going to be one more than the end index of the my right subtree. So I'll rephrase. Previously I said wrong. I'll rephrase it. What I am saying is, my starting index for this right subtree is going to be one more than the end index of my left subtree, right? Let's write this. My starting index is going to be one more than the end index of my left subtree. What was my end index of my left subtree? It was PSI, that is starting index plus total number of elements, plus 1. This is going to be what? This is going to be my starting index. And what is going to be my end index for pre-order? It is going to be nothing but n-1. And what was this n-1? This was my end index of pre-order, right? Now similarly, for this post order, that is also going to be same. That is also going to be the same value, that is IDX plus 1. It is going to start from IDX plus 1 until when? Till which point? Here you can see that IDX was still here. We have to start from here, but we have to end here. That is one less than from the last value. Therefore we are going to write here what? We can write it as n minus 1, or we can write as till post orders end index -1. So with this, with these values or with these pointers, I can construct my whole binary tree using these values and these pointers. Right, now let's try to code this. I hope the explanation part was clear to you all. How actually we did, we just instead of looking here and there, or I'll say that instead of looking directly for the root value in the post order, we searched for the next value in the post order. That is, we directly searched for which value? We directly searched for B. Instead of searching for A, we directly search for B in this whole array, and using that IDX point, that is using the position of this B in the post order, we were able to find the total number of elements that we can send in the left subtree, and that after those we can send in the right subtree. Right, so let's try to code this thing, and after that you'll be able to understand more clearly. And after that we are going to discuss one more thing, that is going to be why it is compulsory to have a full binary tree for this question, like how these properties are actually useful to us and how these properties are going to help us in the future questions. So let's code this. So let's code this question. Initially, what we will be provided with, we'll be provided with one vector that is going to store the pre-order, second vector that is going to store the post order. So let's initialize a variable in 10 that is going to be size of this pre and post order. Obviously the size for both of this is going to be same, so we'll be using any one of these size. And now we are going to return what? From here we are going to return a function. We are going to return value that is being received by a function named as build tree, and in this build tree function the actual work is going to be done. So here we are going to write what? Build tree. We are going to pass our pre-order array, that is going to be pre starting index, that is going to pre-order starting index, that is going to be 0, end index. Then we are going to pass our post order array, and then we are going to pass the starting index and the end index. So these are the four values what we are that we are going to pass. Right, now let's start with this function. What actually this function is going to be? Build tree. This function is going to receive what? First, a vector of int type that is going to be named as pre-order. Let's name it as pre-order. It is going to receive its starting index, that is pre-order starting index. It is going to receive pre-orders end index. It is going to receive another vector of post order that is going to be of int type. So post order, right? Percent. Here also it is going to be and percent. Now here it is going to receive an integer value that is going to be starting index of this post order, so post order starting index. And second thing, it is going to be another integer that is going to be end index of this post order. So initially what we were doing, first, as we come in this, we are going to create a tree node. Let's say it as node, and what values we are going to give it? We are going to give it as new tree node with value of post order, that is post orders starting index. Right, so this call is actually going to create a node, that is node A. That is, it is going to create node A with using what value? With A, with using this PSI value. Right, now second thing what we are going to do, we are going to find the index, that is IDX. So this idx is initially going to be where? Idx is initially going to be 0, but actually it is not going to be at 0, but it is going to be at the starting index of this post order, because we want to traverse in post order. Therefore we are going to keep our idx here, and then we are going to traverse. So that value is nothing but post order's starting index, right? Now how we used to find the idx? We used to what we are going to do, we are going to search in this array, that is in the post orders array, till we get value what? Till we get value b, and that b is nothing but the next value of this a. So we are going to do that post orders idx is not equal to pre-orders starting index next value. That is, initially it is going to lie at the starting index, and we have to find the value for the next index. So till not next index, till then increase our idx. Right now our idx, that is index, is lying at this position, that is it has iterated through this array and it has found the value in the that is terminating this while loop. So it is actually at this point. So now what we are going to do, if we get our idx, we will be finding a total number of elements. So this is going to be what? As we have wrote the formula, this is going to be idx minus starting index plus 1. So idx minus starting index of post order. So post order starting index plus 1, right? And then our calls are going to take place, that is node left is going to take place. So what are the values we are going to send in the post in the left subtree? So the values are going to be, first array is going to be as it is. Now what will be the starting index and what will be the end index? I'll give you the reference. As we have wrote here, we are going to use these values only. We are going to pass these statements only as it is. So what we are going to do here, as we have wrote what? Starting index, that is starting index of pre-order, and till when what will be the endpoint? It is going to be at the starting index plus total number of elements, that is starting index plus total number of elements, that is going to till where? Starting index plus total number of elements, that is going to 1 2 3 4 5 till f. We are going to send till f. But as this a is being already included here, will we are we going to send this a again here? Like if we start from this position and we go till f, a will also be included here. So instead of doing that, what we are going to do, we are going to start our new starting point, that is going to be at this position, that is going to be starting index plus 1. So we are going to do the same thing. So here I guess I have written wrong, it is going to be starting index plus 1. That was our mistake. So here we can see that as we started coding, we were able to get more insight to that if what we have written is going to be correct, going to be satisfy our conditions or not. So as we have noticed that it is going to be starting index plus 1. Why it is going to be starting index plus 1? Because if I send my starting index as it is, a will be also included, so a will come here. Therefore we don't have to send our starting index, so it is going to be starting index plus 1. So we are going to write it here. We are going to pass starting index of what? Pre-order starting index plus 1. What is going to be our end index? Let's check what is going to be our end index again. If we are at till this position, that is if we are at currently this position and we have to go till this point, this is our starting index plus 1. But if I add my total number of elements in this at this particular point, that is going to be 0 plus 1 plus 5. This is going to give me 6. But we don't want to travel till 6. That is, if we travel till 6, that is going to be 1 2 3 4 5 6. It is going to give till g. So we don't want to proceed till g. We want to end our loop, or we want to send our pointer till this point, that is this f is going to be our end index. So what we have to do, we have to consider this 0, but we don't want to consider this one. So what we will be doing, we will be just adding total number of elements as it is. So as we have written here, psi plus total number of elements, so it is going to be go as it is. So starting index plus total number of elements. Now second thing is going to go what, post order. Now its starting index is going to be what, its starting index is going to be as it is, that is post order's starting index. So post order starting index. And now what will be its end index? Its end index is going to be idx, because we are maintaining our idx at this particular point. So it is going to send idx, right? Now for write, what we are going to do, for write we are going to change this starting index. What is the starting index going to be? It is going to be one more than this psi plus tnel, that is total number of elements. So I'll be just adding this total number of elements here, right? And what is my end index going to be? My end index is going to be till as it was, that is, it is going to be this end index, right? Now similarly for post order, it is going to be what, it is going to, starting index is going to be idx plus 1, right? And end index is going to be what, end index is going to be post orders end index minus 1. Why minus 1? We have already discussed, because we are not going to include this a again, as we have not included a here, that is, we have not included this a while passing the starting index. We are not going to include this a. With this our calls are complete. So in the end we have to return what, we have to return node. Now time for our base cases. What are our base cases going to be? If our node is equal to null, sorry, here we are not checking for the node values. Obviously these base cases are going to be same as the previous base cases, that is, if my starting index of pre-order is greater than my end index of pre-order, that is pre-order's end index, then do what, then return, right? Second thing, if my psi, that is starting index of pre-order, is equal to end index of pre-order, this means that it is just going to have one node. So just return a new node with value as pre-order starting index. Here we can write end index or starting index, it's up to us. This statement means that we are having just one value of one value in the whole tree. So therefore with this our code is complete. Let's try to run this code and see if there are any errors or not. So there are some errors. Let's see what are those errors. It is saying that expression cannot be used as a function. Let's see. So here it is saying that expression cannot be used like psi. Okay, let's see. Starting index plus tnel, as we have discussed, that starting index till total number of elements. And in the next call, what we are going to send, we are going to send this, and end index is going to be this. Okay, so psi till n plus 1, right? And end, okay, end index is going to be, it is actually going to go out of bound. And next thing it is going to say is, let's try to run this. Okay, it is still giving the expression cannot be used as, okay, expression cannot be used as a function. Okay, right. So this is actually going to be equal to, that was our error, because this is an expression and we cannot use it as a function. So what we are going to write here, we are going to actually call our build tree function. So this was syntactical error. Let's now try to run this code and see if there are any more syntactical errors or not. Okay, it is now getting successful. Let's try to submit this. Okay, wrong answer. Why wrong answer? Let's try to take one test case. Now, okay, so output should be something like this. And what was our output coming? It is not actually showing us. Let's try to figure out that what we did wrong. Okay, let's start from here. We are going to send n-1, right? Now what we are going to do, we are going to take, we started from here, we pass correct values, that is 0 n-1 post 0 n-1. Okay, pre-order, yes, if my starting index is greater than the end index, return null pointer, right? If my psi is equal to end index, sorry, if my starting index of pre-order is equal to my end index, this means that there is only one value, right? And that is going to be my node. Okay, it is also right. Second thing, what we are going to do, as we come in this, we are going to create a new node, tree node of post order. No, here it is going to be pre-order. This was our mistake. So because of this, actually it was giving us the error. Let's try to run this code. Let's try to submit this code, and all the test cases are passing. So what was our mistake? That was again a syntactical silly mistake, that instead of pre-order we wrote post-order, but the logic was correct. What was the logic? The logic was, sorry, the logic was to start from this in pre-order and to search for the next element. Now, as I have said, if you remember, I have told you that we are going to discuss that why these properties are actually main properties. So let's see that how why this constant is given to us, that the for constructing a tree, binary tree from pre-order and post-order, the tree must be a complete binary tree. Complete binary tree. Why it is telling us this? It is because, let's say, I'll give you one example, and if that example is clear to you all, then you will be able to understand that how this properties of pre, in, and post are really helpful. What are these properties? These properties are, first we visit node, then left, then right, then for in order we visit left, then node, then right, and for this we visit left, right, and node, right? You will be able to understand that why these properties are really important. Now tell me the pre-order and post-order of these trees. The tree is something like this, and second tree is something like this. Okay. As you can see that, as you can visualize that these two trees are different trees, right? But what will be the pre-order and post-order of this tree? For, let's say, A and tree B. For tree A, what is going to be pre-order and its post-order, and what is going to be pre-order of tree B, and post-order of tree B? If you notice that, if you have paused this video and you have tried yourself, you will be able to notice that these two trees are giving the same values for pre-order and post-order, right? Let's see. Pre-order is going to be 1, 2, 3, 4, right? Similarly for this tree, let's first calculate the post-order. It is going to be 3, 4, 2, 1. Similarly for this tree, it is going to be 1, 2, 3, 1, 2, 3, 4, and it is going to be 3, 4, 2, 1. Now with this you can see that this tree is not a complete binary tree. Why it is not a complete binary tree? Because it is missing this one child. This is also missing this one child. And as by the definition of the complete binary tree, either the node can have 0 child or 2 childs. but cannot have one child, right? So with this you can see that the pre-order and post-order that are coming for these two trees are same. So you can say that so because of this thing we can see that if the tree is not a complete binary tree, we are going to get so we can say that same solutions or same pre-order post-order for different trees. So if a tree is a complete binary tree, then we are going to get a unique pre-order and post-order of that tree, right? For example, if I instead of if it was not empty, if I wrote here, let's say 0, and here also I wrote 0, then what was the pre-order and post-order of this tree going to be with this 0 value? It is going to be what? First pre, let's calculate the pre and then post. Here also let's calculate pre and post. What are those values going to be? First it is going to be 1, 2, 3, 4 and 0, right? And post value is going to be 3, 4, 2, 0 and 1, right? And here it is going to be what? 1, 0, 2, 3, 4, and post order is going to be 0, 3, 4, 2, 1, right? Now you can see that this tree is now a complete binary tree. It is giving us a unique solution, right? Unique solution. And this tree is also a complete binary tree, therefore it is also giving us a unique solution. So therefore these properties are really important for us. So with this, I hope the question was clear to you all, and also this difference was clear to you all. So thank you for this video. Let's meet in the next video.